Now again, one more thing that I have told, again we have taken phi f star into psi dx, am I right? This is the probability amplitude. So probability of state, so getting the state phi f, that's equal to mod square of this one, am I right? We have taken this one. So the idea is actually, again always, we need to expand. Again, what is this one? This is the coefficient mod square, Cn mod square, am I right? We have seen. The idea is writing psi, actually you better write like this, okay? Final state should be one of the eigenstate. You better put some integer. Is that okay? Final state is usually one of the eigenstate, okay? Let me put n, pi n. Pi n looks like eigenstate, am I right? Pi may be anything, any function, is that it? Pi n looks like eigenstate. That's why, so rather than pi, let me take pi n, okay? So what is the probability of getting particular final eigenstate, okay? So that is the question actually. So now look at here, the idea is this state, this is the initial state on which you are doing the measurement, should be expanded as linear combination of eigenstate of measuring operator. Let me upload a note on this one, okay? You have to visit that one again and again, okay? So then what does it gives? This whole thing will give you Cn. What is Cn here? Just like in case of psi n, I have taken pi n, that's it, okay? Integral of
what is phi n, sir?
eigenstate. Phi n's are eigenstates. Eigenstates of measuring operator. Initial state on which you are doing the measurement should be expanded as linear combination of eigenstates of measuring operator. Here it is energy, that's why we have expanded as psi n. Psi n is the energy eigenstate. Later some other measurement idea comes, okay? Then you have to expand that one in terms of that eigenstate. You will see that one. Is that okay? This is not the only one, this one part actually. Are you getting my point? Speak out. What I am saying is, so this is one of the part. Now look at it. We have written Cn into psi n, am I right? So your initial state you have written in terms of Cn into psi n, because you want to do energy measurement on that one. That's why you have expanded as energy eigenstate, okay? If you want to do momentum measurement, you should expand that one as momentum eigenstate. You will see that one later. Or if you want to do spin measurement on any state, you should expand that one as spin eigenstate. You will see that one. This will become a theorem actually. Okay? Initial state on which you are doing the measurement should be expanded as eigenstate of measuring operator. Here it is energy eigenvalue, eigenstates, okay? In this case. Later we shall see other ideas, okay? So where Cn is equal to phi n star into psi I, this psi dx, isn't it? And this is Cn mod square. This whole thing is nothing but Cn mod square. That you need to get the idea. This Born interpretation, initial state, final state, we call this one as inner product. Look at here. This whole thing is written like this, okay? Phi n into psi I, initial, this is final. Is that okay? Inner product between initial and final state and integrated. But remember, these two should be normalized. Then only that has meaningful. Isn't it? When this is normalized, then only mod Cn square, that is meaningful, am I right? When this is normalized, otherwise that is not meaningful. Okay? Careful. Is that clear? So that is the basic idea that I just copied from Jetili. He hasn't mentioned that one. But final state should be eigenstate of measuring operator. Okay? Yes. Why he hasn't taken that one? Because in case of energy, you have discrete energy level, okay? In case of momentum and position, you will not have discrete eigenstates, okay? You will see later that idea. Now, that's the best idea. Is that okay? Now look at it. The problems will be given like this, okay? The particle is in ground state of 1D box, okay? So from 0 to A. Box is from 0 to A. Is that okay? Particle is in the ground state, okay? particle is in the ground state of 1D box from 0 to A. That means particle wave function is like this. Is that okay? It is in psi 1 state. Okay. What is your initial state? Psi 1. Okay. So let me call this one as initial state. That's psi 1 initial state root of 2 by A sine phi x by A, n equal to 1. Okay. Ground state. What is the energy? Pi square h bar square by 2m A square. Okay. Now look at here. Right side wall is suddenly moved to 2A, A to 2A. Right side wall suddenly. This is very important. Okay. If it slowly moved to 2A, so then we need to go for some other theory. Okay. Let me introduce that one later. Okay. If it moves slowly, suddenly within no time. Okay. Suddenly moved from A to 2A. From A to 2A. Okay. So that initial state or wave function is momentarily unchanged. Is that okay? What happened? Again, particle is in the ground state of 1D box from 0 to A. Now we suddenly move this one. Okay. What we are doing here is, this is 0, this is A, this is 2A. Okay. We suddenly moved that right side of the wall from A to 2A. Is that okay? So that initial state is momentarily unchanged. This state is unchanged, like that. You suddenly move this one. Is that okay? Now they ask the question that after this sudden movement, now you are doing the measurement. Okay? Immediately you are doing the measurement. Now what is the probability of getting the particle in the ground state of the new box? This is the new box now. Okay? After this what you call sudden movement of this right side wall, you are doing the measurement now. Is that okay? So now in this case, now you are doing the measurement on which state? On this state. Okay? On this state. Now what is your initial wave function? So that's equal to root of 2 by A sine pi x by A, when x is between 0 to A, it is 0 outside. Don't forget. It is this function only, but it extends only between 0 to A. Is that okay? So can I call this one as psi 1? It was a ground state of old box actually. Right side wall is suddenly moved from A to 2A, so that wave function is momentarily unchanged. This is how they define the problem. Okay. And after this one, you are immediately doing the measurement on this new box. Okay, on this state. What is the probability of getting? What is the probability of getting ground state of new box? So can I write like this? What is the probability of getting first excited state of new box? These are the questions that they may design. Are you getting my point? This E1 new means, En new means, what is this one? N square pi square h bar square by 2m 2a the whole square. Remember, are you getting my point? Again, after this sudden movement, the system is this one. You are doing the measurement on this one. You should get energy eigenvalue if you do energy measurement, isn't it? Is that okay? What are the eigenvalues of this new box? Eigenvalues of new box, A should be replaced by 2A, isn't it? Are you getting my point? Yeah. So this would be the question actually. Is that okay? Have you written this one? Particle is in the ground state of 1D box right side wall is moved suddenly from A to 2A, okay? So that wave function is momentarily unchanged. Okay, wave function was like this. Okay, initial wave function, it was in the ground state of old box. Okay, what is the corresponding energy? Pi square h bar square by 2m square. Okay, pi square h bar square by 2m square. Now right side wall is suddenly moved from A to 2A, 0 to A, 2A. Is it okay? Right side wall is suddenly moved from A to 2A. So that your wave function is momentarily unchanged. This is unchanged. Is that okay? So what was this psi I? Psi 1 I is equal to root of 2 by A sine phi x by A. Okay, remember this range is 0 to A. So now again the initial state is unchanged. Okay, that's equal to root of 2 by A sine phi x by A. X is between 0 to A, 0 otherwise. Is that okay? Now look at here carefully. Now in the new system, this is not any eigenstate. Isn't it? In the new system, your eigenstate wave function should be like this, am I right? Ground state wave function like that, isn't it? Yeah, that you need to remember. What is the energy eigenvalue of new system, new box? That's equal to n square pi square h bar square by 2m into 2a the whole square. Don't forget this one, okay? Here it was, again, it was in the ground state, or if you write en old n square pi square h bar square by 2m a square, but it was in the ground state actually. What is this one? Pi square h bar square by 2m a square, okay? Now the question is, what is the, again, now you are doing the measurement on this one now. After sudden expansion, wave function is unchanged, okay? It is retaining its old functionality. This is equal to sine pi x by a between 0 to a and equal to 0 in the outside region. And now you are doing the measurement on this one. What is the measurement you are doing? Energy measurement, okay? Now what is the possible outcome? What is the probability of getting ground state energy? What is the probability of getting ground state energy in the new box? What is the probability of getting first excited state energy in the new box? Like that, the question, okay? Now what you have to do? The state, the initial state on which you are doing the measurement, speak out. This is the state on which you are doing the measurement. Should be written as linear combination of eigenstate of measuring operator. Now your system is new system. That's why again you should be expanded this one as eigenstate of new box, because you are doing the measurement on this one, isn't it? Is that okay? Now this is the new eigenstate, remember. So this is the new eigen value. This is the new eigenstate. Psi n, that's equal to root of 2 by 2a sine n pi x by 2a. So can you see this one on Google Meet?
Yes, sir.
Root of 2 by 2a sine n pi x by 2a. Okay, that is the new eigen function. That's the new eigen value. Okay. Now again you need this Cn. Am I right? Cn is equal to integral of psi n mu into psi I initial state. Is that okay? Dx. Speak out. Isn't it? And you can take mod square. Now if they ask what is the probability of getting the particle in the ground state, look at here my words, okay? what is the probability of getting the particle in the ground state of new box? That means what is the probability of getting E1 new, isn't it? What is the probability of getting the particle in the ground state means probability of getting E1 energy, ground state energy, isn't it? Speak out. So now this is nothing but, so probability of getting psi n new, isn't it? Psi 1 new, psi 1 new, isn't it? Because I'm asking you about probability of getting ground state, isn't it? Now this should be final state now, isn't it? After the measurement, this should be final state. Speak out. Speak out. Yeah. After the measurement, this should be final state. I mean, you should collapse to that particular eigen function, isn't it?
Oh, yes.
Final state. Yeah. So that's what I'm saying. Probability of getting the ground state of new box. Okay. So that is equal to probability of getting ground state wave function. That's what we simply say, isn't it? Now that's equal to of new box. So don't worry. Yes.
But side of wave function should be 0 to A.
Wave for initial state is 0 to A. Initial state is 0 to A. Now look at here. Now again you need to Fourier expand this one in terms of states of new box. And you need to find the coefficient. Are you getting
They
it?
are saying that initial state wave function is momentarily unchanged.
Unchanged. It is 0 to A. That's correct. Look at here. So anything can be expanded as a new wave function. Why not?
That can be.
Isn't it? Any function can be expanded in terms of new wave functions. That's what you are doing. Look at here. You have done that problem. Am I right? Particle is equally likely to be in the left half of the well. It is 0. And you expanded and you found coefficient, isn't it? Particle is equally likely to be in the left half of the well. So it is 0 in this region, but still you expanded in terms of states, isn't it? Like that. This is one function now. This is one initial state now. You have to expand this one in terms of this one. Are you getting my point? That's what I have written here. Earlier step, what I have written is this initial state, you should expand this one as Cn into psi n new. Is that okay? And you need to find the coefficient. Coefficient mod square will give us probability answer. Try to understand this problem fully because quite repeated. Yes. Yes, pick up.
How do we write wave?
How do we write?
So wave function at later time.
In this particular problem, he is not asking wave function at later time. Okay. Suppose if you write this is the initial wave function x comma 0. Okay. Cn into psi n new. So later time, if you want to put t, you just put e power minus I en new t by h bar. That's it. That part is not changing. Okay. You have to just plug in exponential factors. Okay.
Yes.
That's same as earlier. Is that okay?
Factor.
Speak up.
With respect to new wave function, we will write.
Yeah, again you have to this now your system is not this one. You forget about this one. They have given this one only to say that this is the initial state. Are you getting my point? They could have said particle box length from 0 to A and wave function is like this. They could have said like that. No, they haven't said like that. What they said is particle was in the ground state of old box. This is suddenly moved so that this happened. Okay, and you are quickly doing the measurement. You are not waiting for later time. Are you getting my point? This problem is like that. Suddenly you are doing the measurement on this one. Okay, you don't go for what you call time evolution of this one. Even if you go for that one, you have seen, am I right? These probabilities will not change, isn't it? Energy measurement probabilities will not change. Is that okay? So that's why you need that what you call probability of getting En new. Probability of getting any particular eigenstate of new box. So that's nothing but mod Cn square. That's nothing but mod square of psi n new star into psi I. This was the ground state of old box. Okay, remember dx square. Between 0 to A, you have to integrate, so between 0 to 2A actually, because you have to integrate over full region of interest. Are you getting my point? You have to integrate over full region of interest. Speak out. Is that okay? Now look at here. This is what he is saying in this problem is this is the initial state. That's it. Okay, that's why he started with this one. That's it. Okay, this is the initial state. Now you are doing the measurement. That means initial state should be expanded as eigenstate of measuring operator. Now measuring operator, everything is related to new box. You should expand that one as eigenstate of new box.
Because we have a tool, sir.
Yes.
We have a tool like that, we can generate any function.
Yeah. Again, these are complete. Okay, these can generate any function. Those are complete. Okay, they can form a basis. Okay, it can generate any function. Is that okay? So then look at here. Again, what is the probability of getting some nth eigenstate of new box? That's equal to mod Cn square. Is that it? Where Cn is equal to integral of psi n new star into psi I. Don't forget this psi I is the ground state of old box. Okay, so you have to integrate from 0 to 2a because you are dealing with a new box. But what will happen is this region is 0 to a only. This is 0 outside a to 2a. Are you getting my point? This one.
Integration should be 0 to a or
0 to 2a because you are dealing with new box. Your region of interest is 2a. But what will happen? Because of this functionality, it is 0 outside, it will convert it into 0 to a. If you write 0 to a, it would be wrong because you are not dealing with old box, you are dealing with new box. You should integrate throughout the region while finding Cn. But what will happen because of this nature, which is 0 outside, so this integral will be converted into 0 to a. Is that okay? So that's why I have written very clearly, it is root of 2 by a sine pi x by a between 0 to a, and it is 0 between 0 to 2a. But while writing the most general form, you have to take the integral 0 to 2a only. Is that okay? Remember, this integral will, again, don't keep this one as it is and integrate between 0 to 2a. See this one properly. It is 0 when x is between a to 2a. Okay? And otherwise, in all other region, it is 0. Okay? Speak out. Now, just find out that probability. Okay? So, find out at least probability of finding the particle in the ground state of new box. Okay? That means, so these are the theory, but you can write directly. Am I right? E1 nu. What is this one? So probability of getting psi 1 nu. Now then this should be final state. So now integral of, so final state psi 1 nu. This is the final state. Star, this is the initial state. Isn't it? Psi I dx 0 to 2a mod square. Isn't it? Now do this integral. Do this integral. That is nothing but C1 actually. Okay. So that's equal to 0 to 2a psi 1 nu into psi I dx. But psi I is 0 outside 0 to a. That's why it will be converted into 0 to a. What is this psi 1 nu? You should take normalized state. Root of 2 by 2a sine pi x by 2a. Psi 1 nu. Star actually, you should take star, but complex conjugate is itself. Okay. Psi I, what is psi I? Root of 2 by a sine pi x by a dx. You need to find this coefficient, you need to do this integral, sin A sin B formula. Isn't it? You should do that integral, then you have to find mod square. Can you do that one later? There are many just question on that one, 2 to 3 just question. Okay. Speak out. Any question here?
Sir,
Yeah.
is it possible to shift the right one to from A to A by 2 suddenly so that moment could be
Yeah, that kind of problem is not designed because
A to A by 2, then there is probability that the particle is left outside the wall.
No. That will not happen. That will not happen. Now, once you move the wall outside the wall, particle should not be there. Okay. Now you should cut down that one. Is that okay? If you,
Into A by 2.
if you suddenly move here, you should cut down this part actually.
Then the wave function will not full.
No. What it's saying is from A to A by 2, you just suddenly move here. Then what will happen? If you move outside, yeah, it is unchanged. Am I right? But when you move here, again, will it be like this? No. This part again, particle is obstructed. Outside the box, particle cannot go.
It will become this particle.
Yeah, it will be discontinuous. Yeah, that too should be discussed actually. Discontinuous state cannot happen, one thing. And other one is, he has given one discontinuous function. Have you seen? That particle is equally likely to be in the left half of the box. That is a discontinuous function. Yeah, let me check out closely, okay? This is new. Look at here. This is the final state. This is the initial state. Take inner product mod square. Final state, initial state, take inner product mod square. While doing the inner product, look at here, take full region of interest. You are dealing with a new box. Is that okay? But because of this nature, which is 0 outside, am I right? That integral will be converted into integral of old box, okay? Yeah, speak up. I hope you got the theory. Now look at here. Let me read this just question. So this is a particle in one-dimensional infinite square well between E minus L by 2 to plus L by 2. Between minus L by 2 to plus L by 2. Is that okay? Particle is in the ground state. The particle is in the ground state of this one, okay? Psi naught. He mentioned psi naught or whatever, okay? This is the initial state. What is the initial state? What is the initial state? Quickly. Not sine function. Root of 2 by L. Length is L only. Cos pi x by L. Okay, this is the initial state. Okay. Now look at here. The walls of the box now moved from the moved so that it is extending between minus L to plus L suddenly. Minus L here somewhere, plus L here, okay? Minus L here, minus L by 2, plus L by 2, plus L here. The new box, and it is suddenly done so that this wave function is unchanged. This function is unchanged. Is that okay? Speak up. Very important problem. Repeating. Now, what is the probability that particle will be in the ground state after sudden expansion? Ground state of new box. That's what he's asking. Okay. What is the probability of finding the particle in the ground state? Isn't it? So to find this one, what you need? Psi 1 new star initial state, isn't it? Psi I dx between minus L to plus L, but this state, look at here, this is 0 outside. This is the psi I on which you are doing the measurement. It is 0 outside. That's why this minus L to plus L, it will be converted into, speak out, minus L by 2 to plus L by 2. What is psi 1 new? Speak out. Root of 2 by 2L now. 2 by 2L, because box again, eigenstates, so corresponds to box of length 2L. Cos pi x by 2L. Okay? Into, so this is this one. What is the initial state? root of 2 by L, because it was ground state of old box, am I right? Cos pi x by L dx. Then you need to take mod square. Initial state, final state, inner product, we call this as inner product, mod square. Speak out.
Sir,
Yes.
sir, why we take limit of first initial state?
No, look at here. Actually, you should write this initial state like this. Actually, it is root of 2 by L, because now our region of interest is minus L to plus L, isn't it? Earlier, you just write like this, because we already know that our region of interest is minus L by 2 to plus L by 2. We don't quote that it is 0 outside like that. But now our region of interest is minus L to plus L. So we have to quote this one, cos pi x by L, between x is between minus L by 2 to plus L by 2. Okay? And it is 0 outside. Now you are substituting this one here. Are you getting my point? You are substituting this one here. But here you need to do throughout the region of interest. Okay? But since this is 0 outside, minus L by 2 to plus L by 2. You can see here, that's what I have drawn here. This is the initial state. It is 0 in this region. Is that okay? That's why this integral will be converted like this. Is that clear? Speak out. Where C1 is given by like this. Now let me quickly ask the question. Okay, what is the probability of finding the particle in the first excited state of new box? Quickly tell me, without solving. Why? Why?
These are definite energy states.
So again, this is also definite energy state. You got some non-zero integral. If you solve some non-zero value, this was also definite state. Why is that 0? What is the probability? Write down that one. Write down that one. Without writing down, how do you guess, isn't it? Speak out. Don't look here. Here you can't find. Write down that one. Write down. No. Look at here. How this wave function can be orthogonal to that wave function. In the new box, if you write set of wave function, they will be orthogonal. Yeah, write down. Write down this one. This is C2. What is C2? Minus L2 plus L. Psi 2 new. Speak out. Into psi I dx. Substitute. What is this one? C2 minus L by 2 to plus L by 2, because psi I region is that one. Okay. So what is psi 2? What is psi 2? Speak out. What is the first excited state of psi n nu? It will be root of 2 by 2L cos n pi x by L. N pi x by 2L. N is equal to 135, isn't it? Root of 2 by 2L sine n pi x by 2L when n is equal to 246, and isn't it? What is psi 2? Speak out. Speak out. Speak out. Root of 2 by 2L sine 2 pi x by 2L into what is the initial state? Cos root of 2 by L cos pi x by L dx. Limit is symmetrical. Even function into odd function, isn't it? You should know that initial state is even function. You are asking probability of getting final odd function, isn't it? That cannot happen.
But in the fast error state, the pattern of the wave function, it will be like
No, whatever. But mathematically it is not allowed. Again, your first excited state wave function is like this. First excited state of new box. You are asking question about new box, not old box. Speak up.
Directly, we can't say directly.
No, you can't say directly. You have to write down. You should say that it is correct to say because of this oddness of the function, it is 0. Even function can be expanded only in terms of even function. You have seen in Fourier expansion, isn't it? In its expansion, in the expansion of this even function, again in the expansion in terms of this one, okay? In terms of this one, only cosine function will be there. Sine function cannot be there. Just like Fourier expansion. Yes, speak out. Yeah, any question? That's equal to 0. So you may get probability of getting n equal to 3, okay? Second excited state, okay? But you will not get probability of getting n equal to 4 state. Again, that will become odd function. Speak out. So can you do those problems from just question before evening, okay? Actually, I put deadline as tomorrow evening. I'll put deadline as today evening only, okay? So that I need to start next topic tomorrow.
All questions, sir? All questions?
All question. I think you can do. Some questions are repeating, okay? Whatever in the last assignment, I just gave that one, okay? And some questions are on particle in a box. I think you can solve. Apart from this one, I don't know. I'm not finding any new, type of, yes, question. Speak up.
So can we calculate after how long time?
After long time also, look at, you are suddenly expanding and you are waiting, am I right? That's what you are saying. Then initial state at 0, at t equal to 0, you are suddenly expanded, okay? Summation over Cn into psi n nu. Once box length is expanded, your system is this one, your system eigenstates are this one. Correct my point? Yeah. Now psi I x comma t, speak out. Summation over Cn into psi n nu into e power minus I e n t by h bar nu. T by h bar, isn't it? Now again, what change that happened compared to this one? Cn is accompanied with this one, am I right? Isn't it? Cn into e power minus I e n nu t by h bar, okay? Into psi n nu. Now you got new coefficient, that's true, but what is mod square? Same as earlier. Energy measurement, again it will not change even after some time. Energy measurement answer, okay? But your position measurement answer may change, okay? Again you have seen that's again in case of two state, linear combination of two state, it's a sine function. Mod psi square is a sine function, sine omega t. Have you seen that problem? Isn't it? Yeah. But energy measurement, so again this mod square, that is same as Cn mod square, okay? We are finding that Cn mod square. Is that okay?
Yes, sir.
Yeah. This is the time evolution, but they are not asking any time evolution. They are asking, suddenly you are doing the measurement, okay? What is the probability of getting the ground state of new box? What is the probability of getting first excited state of new box? Like that. Okay? Read the question properly and try to solve it yourself. Grab the idea, try to solve the problem, because this is exactly same as initial state, final state, inner product, mod square, Born interpretation, okay? But you should be very careful. You should know what is the initial state, what is the region of that one, initial state. Where initial state is non-zero, where initial state is 0.
So whenever
We should know what is the final state wave function, that's it.
whenever we take the integration in a new box, we will take always the initial wave function, limit.
Because initial wave function itself is 0. But whatever the calculation you do here, you should take minus L to plus L. You take that one, but initial wave function is 0 outside. That's why that limit will be obviously converted into minus L by 2 to plus L by 2. That's what I'm saying. That doesn't mean you should initially put minus L by 2 to plus L by 2. How do you know that one? That would be wrong in principle. Are you getting my point? How do you know that one? Isn't it? How do you know? Again, after substituting this initial wave function, you have to convert your limit to minus L by 2 to plus L by 2. Is that okay? Yeah, speak out.
And sir, here initially it is in even state, so we have it expanded in terms of even function.
Even you should, in its expansion, this only even, since it is even state, it should contain only these terms. You will get probability of getting one state, third state, fifth state, not any of this sign function, sign state. N equal to 2, 4.
Actually, initially when it is in odd function, then we have to expand in terms of odd function.
It will be odd. It will be odd. But they don't give like that, okay? They give ground state, always, okay? In exam, they design like this, okay? Particles in the ground state. If they design that kind of problem, I hope you can handle, okay? Speak out. Yeah.
So is there probability that particle will be in the second excited state?
Second excited state, if, ground state, first excited state, second excited state, n equal to 3. Yeah, can be there. Cosine into cosine, you will get some non-zero value integral, okay?